Hello, and welcome to Canyon Professional Development. Today, we will be spending time together focusing on facts and fluency, unpacking the power. We will be talking about how we can best support our students in becoming proficient with multiplication facts. My name is Carolyn Mann, and I am the Director of Special Projects at Canyon Professional Development. I have over 27 years in education, and I am excited to be here with you today. Today, we will be focusing on the importance of exploring the research behind procedural math fact fluency. We will also take time to look at the three phases that students progress through as they master basic multiplication math facts. In addition, we're going to examine a variety of activities that you can use in your classroom tomorrow to help your students develop fact fluency. And we will end our time thinking about next steps and the instructional practices that I hope you will take back to your classroom. I wanted to start off with a quote, and I chose this one because I thought it was funny, for one, and very true. Math, the only place where people buy 60 watermelons and no one wonders why. If we think back to our days as math students in the classroom, we often had word problems that had things like the man was going to buy 60 watermelons. And come to think of it, I never asked why, but that's a little unusual. Let's help our students start to ask more questions, start to seek the why. To get us started, I want to make sure we do two things. In just a minute, I'm going to ask you about your experience as a student. But before I do that, I want to encourage you to pause this video and download the handouts if you haven't done so already. So at this point, pause the video, take a minute, download the handouts, and meet me right back here. Okay, now that we're ready, let's get started. So, on a scale of dogs, which picture represents your experience as a student learning your multiplication facts? Take a minute to think about it. If you're working with somebody else, feel free to pause the video and to share your responses. I wish I were there with you now so I could hear what you have to say. However, I'm going to share my experience. And over the years as an educator, I have found that my experience wasn't an isolated one, that a lot of people shared the same experience. I would say I was a 5. I was a diligent student who tried very hard and wanted so badly to impress my teachers, to make them happy, and to let them know how hard I was trying. However, when it came to multiplication facts, they did not come easily to me. I remember week after week taking those multiplication fact tests and seeing those students pass them on the first try. And I would feel discouraged when I missed by 1 or 2. Not to mention the anxiety and the racing heart that I felt as I began to take that test, only to sit there counting the seconds in my head until the teacher was going to say stop. As a student, if I'm going to be honest, it made me feel a little hopeless. I felt like I just wasn't as smart as the other kids. Now, I know that's not everybody's experience. I remember the number 4s, the ones who are like, yes, it's time for the time test. It's time for me to show what I know. And that's great. That's great for that small group of students who can excel and who are able to memorize and regurgitate math facts at the drop of a dime. But my guess is that the majority of you watching this video did not share that experience with number 4, or even with number 3, where you felt like, oh, it was a little tough, but I keep getting it. I think more of us would maybe fall into the 1, 2, and 5 category. So as we go through this session, I want you to reminisce about your experience. And as I share different strategies and ideas and research behind students acquiring a proficient understanding of multiplication facts, I want you to think about how your teachers could have possibly supported you in different ways to make the experience more pleasurable and to make you feel successful. So first of all, it's important that we define what is fluency in mathematics, particularly multiplication fluency for the sake of today's session. Well, in general, fluency is known as having an efficient and accurate method for computing. Students exhibit computational fluency when they demonstrate flexibility in the computational methods they choose. understand and can explain these methods, and produce accurate answers efficiently. When I look at that definition, that is not what would come to mind if I thought back to my own experience. I knew that I needed to be fluent, but I didn't feel like the methods that I was being taught or that I was using, I did not feel like they were very flexible. It was memorize, regurgitate, memorize, regurgitate. There weren't a ton of computational methods that I was being taught or the ability to come up with different ways to articulate the answers on those time tests. How about you? Well, there's some important things we need to understand. Knowing from memory is not the same as memorization. Knowing from memory means that you have a variety of strategies, a variety of tools in your toolbox that you can utilize to come up with math facts quickly and accurately. Memorization is exactly what most of us perceive it as. It's when we see something on the page, the answer comes straight out, we put it down. If somebody asks us how we came up with that answer so fast, we would simply say that we had memorized it. We knew that there was a 3 at the top. We knew that there was a 4 at the bottom. It was 3 times 4, and that's just 12, which is okay for the small population of kids who are able to do it that way. However, we know in the long run, if they're not able to share the strategies that they've used or go back to strategies so that they can then solve unfamiliar problems, they might even run into trouble down the line. So, what does the research say? It says, we know that those who learn through strategies achieve superior performance over those who memorize. They solve problems at the same speed and show better transfer to new problems. So I found that very interesting. So yes, we have those students who are able to memorize those and produce them on a sheet of paper if they're given a time test. But it sort of makes me think about when I used to try to cram for tests in high school or college. I would memorize the facts or the information only to regurgitate it on the test the next day. However, if you were to ask me a week later what the answers were, I might not remember. And I am sure I wouldn't be able to transfer that information that I had memorized to help me understand new text or to solve new problems. And that's what the research says about learning multiplication facts or any math facts for that matter. When we teach students to learn strategies to come up with the answers to math facts, down the road, they are more capable and more successful with transferring this learning to new problems. That makes us ask, how do we do this? We need to identify the difference between teaching the strategies, like on the left side of your screen, and simply asking them to memorize. Now, I want to be really clear. This isn't to say that we don't want them to be able to come up with the answers quickly. We know as they move through the grades and they progress in math, they have to have quick recall. And we'll get to that in a bit. But what this is saying is that we need to be supporting them with strategies. So if you look on the left side of the screen, you'll see an example of a strategy that you could use with your students. This is on one of your handouts. These are called number talks. So students are being asked to look at a particular problem. Then they're being asked to solve the problem mentally. Now, this is assuming that they have been working on their multiplication facts, for multiple years at this point. The teacher then doesn't ask just the answer that they got. Instead, the teacher asks the students to share how they solved the problem mentally. Once again, this is asking them to recall strategies that they have learned in the past and to share them during these number talks. Now, if students have simply been asked to memorize, we'd come back to that answer that I shared earlier. I just looked at the numbers and knew the answer. Well, that's great, but that's not as effective when you come to these examples like 21 times 5. That wasn't on your math time test. So what did you do? The teacher could then create a chart detailing all the students' responses and talking about the different ways students came up with the answer. Here at the bottom, you'll see we have 21 times 5. This particular student said, well, I rounded 21 to 20, multiplied by 5, that gave me 100. That was pretty easy. And then I knew I needed to multiply the 1 times 5. Then I ended up with 100 plus 5 equals 105. Now you can look at the other two examples and you can derive what students probably shared as they explained what strategies they used. This is one really effective strategy to help students not only solve the problems, but continue to reinforce that there are different strategies they can use when it's not something that has just been memorized. Now, as students become more efficient with multiplication strategies, they can use them without much thought. They're just second nature. Can you think of any strategies that you use when solving multiplication problems in your head? Do you share these strategies with your students? How might they help? So let's talk about the truth about fact fluency. Mathematics facts are important. There is no getting around that. The memorization of math facts through times table repetition that many of us experienced in practice and time testing, however, is unnecessary and it can actually be damaging. And I already touched on a few reasons why. It can make many of us feel unsuccessful, having to take that same 5 time tests over and over again because we can't seem to finish in the allotted time or get them all right. Why is mathematics treated differently than other subject areas? I have quite the background in reading instruction, and when I began to compare the way we teach math and the way we teach reading, I was shocked when I really took time to think about it. In order to be a good reader or to understand novels or poetry, students do need to memorize the meaning of various words. But if I asked a student in an English class what they think, and if they feel that they need to memorize every word and every meaning of every word in order to be successful readers, they would laugh. Absolutely not, because there is no way that a student can do this. It would be too many words. Do I say they're not good readers unless they can read incredibly fast and when I time them? I do not do that either. Then why do we do that with math? Why do we expect students to memorize an enormous amount of facts and to be able to recall them without using different strategies? When we teach reading, we teach students to decode. We teach them that each letter represents a sound. And when those letters are put together, we blend those sounds together to make a word. And that is the way we need to teach math as well. We need to teach them strategies. There are some misconceptions about math and fact fluency that negatively impact learners on a daily basis. A lot of students are made to believe that math is about getting the right answer. And don't get me wrong, there are definitely times and places where students need to be able to solve and get the correct answer. However, that is not 100% of the time. Instead, students need to learn to enjoy the journey, not just the destination. They need to be able to articulate how they come up with right answers so that they can then apply those strategies in a variety of situations. Another misconception about math and fact fluency is that when it comes to fact fluency, teachers should emphasize the importance of speed. I'm not going to belabor that point because I think I've shared a lot about it already, but just remember that that is a misconception. Let's think about some truths in regard to math and fact fluency. First and foremost, the core of mathematics is reasoning. It is important when teaching students that we focus on number sense and number facts, and we do not emphasize speed. In fact, this is true for all mathematics. There is a common and damaging misconception that a strong math student is one who is quick, who can articulate and recall their facts quickly. However, this is actually not the case. Being able to recall math facts from memorization does not equate to superior intelligence. Instead, intelligence is represented by being able to use different strategies and to come up with different ways to solve problems. I've worked with a lot of educators and a lot of students, and I know even in my own life when I work with people who would proclaim themselves as mathematicians, great at math, or maybe even engineers, that oftentimes when they're solving problems, they are rather slow, which is interesting. They don't quickly identify the solutions and come up with math facts that they recall from memory. Instead, they take their time and they use strategies to solve problems. And by doing this, we can see that there is not a correlation between quick recall and intelligence. Share that with your students. Let them know that thinking is a good thing and that's what they should be doing when solving math problems. Another truth, math facts are a small part of mathematics. Now, before you come at me, because I am with you, I taught elementary school and students needed to know math facts in order to be successful in other areas. This isn't only true in elementary school, this is true throughout the grade level. If students don't know their math facts, then when we get to fractions, they're unable to find common denominators. When we get to algebra, they're not able to solve simple algebraic problems. What I do mean is that they're a small part in the grand scheme of things, and that we need to make sure that we are not stopping students from being able to take part in other activities because they're not quite as fast or as fluent with their math facts. All that means is that we need to continue to provide instruction and review and practice throughout the grade levels until they do become proficient. And last but not least, students need to learn calculating through number sense. Once again, that goes back to those strategies. If a student is still struggling with some of their math facts, they need to be able to apply strategies to help them come up with the answers in a quick and calculating way. And as educators, we need to make sure that we continue to support them with reviewing those strategies and allowing them to practice them, and not just saying they just don't know their math facts. They're just not going to be successful. So how can we do that? One of the most important things that we need to remember is that math fact fluency actually has a sequence. To be quite honest, when I started teaching, I didn't understand this. I understood what it looked like from grade level to grade level in regard to, in kindergarten, I taught numbers and number sense. In first grade, we began to add and subtract. In second grade, we would add, subtract bigger, longer, more complicated numbers. By the end of second grade, we started thinking about some strategies for multiplying, about adding groups of numbers, and things like that. And then third grade, the magic grade. That's those math multiplication fact tests started coming into play when we really started digging into multiplication facts. Of course, that went into fourth grade where those math time tests were more frequent and consistent. And I knew when I taught fourth grade that by the time they left my classroom, it was expected that they would be fluent and they would be able to pass all of those math time tests, numbers 0 to 10, possibly 11 or 12. After that, math fact fluency and the explicit teaching of it, from my point of view, sort of fell off the map. Well, we know that's not true. Let's think about this a little differently. The sequence of learning. Phase 1 is that conceptual learning. That starts taking place with adding and subtracting in kindergarten, first grade, and into second grade. Second grade is when this particular type of conceptual learning really starts to take off, where they're constructing meaning and developing counting strategies. This is a grouping strategy that I was just talking about. They learn that if they have a group of 5, a group of 5, and a group of 5, that equals 15. We can see clearly how this is related to multiplication. At this point in second grade, we might not be making that correlation yet, but we are building that conceptual learning. Number sense is the relationship between numbers and the understanding of operations. This forms the foundation for fact acquisition to occur. At an early age, children begin to develop an important sense about numbers. They start to make one-on-one correspondences, grouping patterns. This is used throughout the grade levels as they go from phase 1 to phase 2 and to phase 3. This takes us to phase 2. As we move to the end of second grade and into third grade, we begin explicitly teaching strategies to help students become fluent with multiplication facts. I share these grade levels loosely It does not mean this can't start happening earlier if students are ready. And it absolutely 100% doesn't mean that this doesn't continue for a much longer period than we might be familiar with. When focusing on the building of basic math facts in phases 1 and 2, this is by far the most crucial time that this happens. During phase 2 is when students seek efficient strategies for solving basic number problems. During this phase, students should focus on the strategies and how they're utilizing the strategies to come up with answers. The answers are the product of being able to utilize those strategies effectively. That leads us to phase 3. As students begin to develop and create a toolbox of strategies, they are then able to apply them to solve multiplication fact problems quickly, striving for that quick recall. Once again, don't forget that does not necessarily equate to just memorization. So increasing the speed in which students select and applies a strategy is what we're talking about here. So they can see the 3, they can see the 5 in their head. They can say, okay, that means I have 3 groups of 5. That would be 15. Quick recall of math facts is usually referenced as the ability to solve a basic number computation in 3 seconds or less. We know that that makes students efficient when working on more complex problems. And this is without resorting to something inefficient like counting on their fingers 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Although that is a strategy, it is not an effective strategy because that would take a long time if they were to do that every step of the way when working on more complex problems. Instead, they are utilizing strategies that allow for quick recall, like this is 3 groups of 5, 5, 10, 15. This is definitely different than that memorization. 3 times 5 is 15. So keep that in mind. So as a review, phase 1, which is creating that number set. Then we have phase 2, which is learning fact strategies. And then students move on to phase 3, striving for quick recall. I wanted to share this quote as we move on to some really explicit strategies for supporting students. I want you to remember that premature drill, starting maybe as early as 2nd grade with those time tests or the flashcards where all they're worried about is getting the right answer, that premature drill will certainly be ineffective and a waste of valuable time, and for many students contribute to a strong distaste for and a faulty view of learning mathematics. So to those of you who at the beginning shared a similar view regarding your experience learning multiplication facts, you shared that view that I had, that it wasn't really positive. This is probably why. But the great news is that as an educator, you can turn things around for your student. We want to think about developing strategies, conceptual strategies, fact strategies, and then moving on to that quick recall phase 3. One of the first things we're going to talk about is foundational facts and derived facts. As a student myself, I don't remember learning this. It doesn't mean that it wasn't introduced to me. We know how we are as students and how our students are. We can teach them something and then their parents ask and they say, oh, no, I never learned that. So I am not saying that this wasn't introduced. I had wonderful teachers growing up. If it wasn't introduced, it was probably because they did not know about this, but you are going to. So when we think about fact strategies, we start with foundational facts and derived facts. Well, what does that mean? Foundational facts are the fact that there's really some rhyme or reason to. And we start with these facts because they're easiest for students to understand and to apply very basic strategies to. And they should be taught in a particular order. You see them on the screen here. So I'll start off with my twos. Students often beginning in kindergarten, even preschool, learn to count by twos. 2, 4, 6, 8, 10, 12, etc. That means when we're learning our multiplication facts, starting with something that they already have an understanding, a conceptual understanding of, they can probably picture groups of 2 in their heads. That would be a great place to start. Now, some people will say, I start with 1 or with zeros because they're the easiest. They're the easiest to memorize, but when we are working on and talking about multiplying by 1 or 0, We really don't have to use a strategy because we just know anything times 0 is 0. We know that anything times 1 equals that number. So yes, they're within the foundational facts, but they're more toward the end. So you see we move from 2s to 10s. Once again, this makes sense. Students often work with counting by tens from an early age. They understand that it's basically adding a 0 to the number. Then we move on to 5s. Once again, kids often learn to count by 5s very early on. Then you'll see we have 1s and the 0s. So yes, there is a sequential order in which teaching these foundational facts. So yes, there is an order that makes more sense and helps students be more successful. After teaching those foundational facts, now they have that base. So you're able to move on to derived facts. What are derived facts? Derived facts are multiplication facts that are derived from other facts. So now that I know my 2s, my 10s, my 5s, my 0s, and my 1s, I can use that information to apply strategies to other facts. So here you'll see 6s. My strategy here might be adding a group. So what does that mean? I'm going to teach my students this strategy. I'm going to think about what I know. Well, I know my 5s, and 5 is really close to 6. So I know 8 times 5 equals 40. I know that I have one more group left. I have one more group of 8 left. So if 8 times 5 is 40, I simply have to add one more group of 8, which means 8 times 6 is 48. I added that one extra group of 8. And this strategy can be used in a variety of different ways. I use this strategy because I'm doing my 6s and I know that 6 is one more than 5. So I can multiply by 5 and just simply add another group of the number. That is our first derived fact. Next, we have multiplying by 3s. Very, very similar. I know that 3 is close to 2. I can simply say, okay, I'm going to double the 4. I'm going to multiply by 2, which is going to give me 8. And then I'm going to add one more group of 4, which gives me 12. You might say, Carolyn, that's very much like the other one. We just moved down to 2. However, they can think about it like that, or they can think that 3 is close to 2. 2 means to double something. And when we multiply by 3, we're actually tripling the number. There's a couple ways students can think about it. To us, those who did not learn multiplication facts this way at the start, truthfully, it might seem confusing, right? We might be like, wow, isn't it easier just to memorize? It might be for some students, and it might be as you're doing it, but down the road, it is not going to be as effective when you're trying to solve more difficult problems or work on more than one computation at a time. Students need these strategies so that they can apply them in different situations. Next, we have multiplying by 4. Basically, the strategy here I could teach is doubling the product of a times 2. So doubling the product, so I have 2 times 7 instead of 4 times 7 is 14, and then I double that. 14 plus 14 is 28. Here we have multiplying by 9s. I sort of had to giggle when I was sharing this one and putting it on the slide because I was thinking, oh, well, I learned how to do 9s with my fingers. I don't know how many of you remember that. However, I probably looked a little silly going to take the ACT using my fingers. So there are other strategies that can be used as well. For example, multiply by 10 and then subtract a group. So we know if I multiply the 7 times 10, that's easy. That's one of our foundational facts. That's 70. But that was one more group than I needed. So I'm just simply going to subtract one group of 7 and get 63. I want you to think, how many of you were provided with strategies like this as students yourself? If you were fortunate enough to be taught about foundational facts and derived facts, do you still utilize these strategies today? Maybe without even thinking about it. We now move on to our 7s. I'm going to be honest, 7s and 6s actually were two that usually gave me a problem when I was growing up. And even as an adult, I sometimes have to think a little harder when I'm multiplying by 6 or by 7. I love this strategy. Here, it says that you're simply going to multiply by 5, a foundational fact. And then you're going to double the number you're multiplying by, add to get the answer. You might be saying, Carolyn, but that seems like a lot of work. Well, not really, because you can do it quickly. We know that 6 times 5, multiplying by 5, is fairly simple for most students. So I can say 6 times 5 equals 30. Then I know I need 2 more groups of 6. So I say 6 plus 6 is 12. 30 plus 12 is 42. Give it a try with another one and see how it works for you. I guarantee the more you practice, the easier it's going to get. And later down the line, it's really going to be helpful for students when they are trying to solve their sevens quickly if they haven't completely memorized them, or it's just not something they're able to memorize. Last but not least, we have our eights. The strategy for teaching this derived fact, eights, is to multiply by 2 3 times. Here we go. I have 3 times 2, that equals 6. Then I multiply that again by 2, that equals 12. And then I multiply that again by 2, and that equals 24. So 3 times 8 is 24. When you teach students this, they are amazed and mesmerized. So go ahead and give it a try. See the excitement when you teach this to your student. Thinking back to the foundational facts that we discussed and the importance of teaching them in a particular order, and the derived facts and the different strategies you can use to teach them, which one are you going to go back to your classroom tomorrow and review with your student? Maybe after seeing this, you're thinking, you know what? I'm just going to start from the beginning again. And that is okay. Now, we've talked about utilizing derived facts and foundational facts. There are a plethora of other strategies you can also utilize with your students. And now we're going to go through a few of those. One of my favorites is multiple representation. I have created this handout for you. Hopefully you printed it up, and we're going to go over how this works. I would share with my students that there are multiple ways to represent math facts. We would then spend time recalling the various ways we have already learned. At this point, yes, I would have wanted to teach a variety of different ways so that students would be able to recall those ways. Now, that doesn't mean you can't start doing an activity like this before you've taught at least 4 different ways to represent facts. You could start off with just 2 boxes and ask them to represent solving a problem in 2 ways, and then move on to 3 and 4. After introducing multiple ways to represent the facts, allow students to create a simple one-pager for a chosen fact. Maybe you are going to give each student a fact so that you can then create a class book where you're going to have representations for different facts, or perhaps you're going to let them choose. Either way works equally well. You'll see here on my example, I chose creating equal groups. I chose using arrays. Then I have context, where I came up with a word problem so that students could see how this could be used in context. And then I used repeated addition. There are other representations that you could use, like skip counting or even an area model. These are just a few ways you can teach students to represent multiplication problems, but remember, the most important thing is that you allow them a variety of opportunities to practice. Some of you might be thinking, I'm busy. We have so many things to cover. How can I do this when I need to move on to the next math lesson? Well, what I'm going to tell you is that it is imperative that you make time, whether this be an enrichment activity that you're adding on Fridays, or something that you're using perhaps as an art project. Maybe this is an art project and you're going to provide them with a variety of different resources that they can use to make a poster where they are representing math facts in different ways. Students love to do things like that. And we're including that multidisciplinary practice between math and art, or maybe math and social studies, whatever it might be. But you can find ways where you are continually allowing your student to practice utilizing these strategies that they have learned. And once again, this does not stop in elementary school. You need to continue providing these opportunities as middle school teachers and as high school teachers. Yes, high school teachers. Because if I were to go into a high school math classroom, an algebra classroom, a geometry classroom, and ask those teachers, are your students proficient with their multiplication tables? I guarantee almost every single teacher would have the same answer: no. Now, instead of saying, this is ridiculous, they're in high school, they should know this, how about we just accept the fact that they need more support and continue to provide them with the strategies and the practice of utilizing multiplication facts in a variety of different ways and assessing them until they do become proficient. Us simply saying they don't know it isn't going to make a difference. The next strategy you're going to possibly want to use is games. As teachers, we are often fond of games, and they can be very helpful. There are a variety of reasons why games are effective when it comes to practicing and learning multiplication facts. We can use games that are sequenced developmentally, games that are appropriate for any age group, elementary school, middle school, high school. They also give students an opportunity for targeted practice where the main objective is utilizing different math fact strategies, opportunity for discussion, figure out and find games that allow students to not only solve but share the strategies they're using. They provide for differentiation. You can modify games to meet the needs of different groups of students. And then last but not least, they're engaging. What child, what teenager, what adult doesn't enjoy playing a game? When they think it's a game, it's not work, it's fun. And we know that when we have fun, learning just takes place. So consider using a variety of games. One of the games that I've shared with you as a resource is memory array cards. I started with some simple facts, but I also left a blank array card for you in case you would like to utilize these to make more difficult cards, maybe for middle school students or high school students. For this activity, you would provide students with 2 sets of cards, one set of cards that has the multiplication problem written out, 4 times 2, 3 times 4, and another card that represents the answer to each of these in arrays. You would provide them with these 2 stacks. They would shuffle these cards up, put them all face down, and as any memory game goes, they would flip over 2 cards, determine whether or not they have a match, the written problem with the array display. If they do, they collect those 2 cards, put them to the side. If they don't, they flip them back over, the next person goes, and this continues to happen until all pairs are collected. The winner is the person who collects the most pairs. Once again, this is a way of having them practice utilizing this strategy, and it is also a way of allowing them to practice in a low-stress situation. The person who gets the most pairs isn't necessarily the person who is the quickest with identifying the answers to multiplication facts. It just might be that their opportunities and the cards they turn over allowed them to collect the most. A variety of students can feel successful when engaged in activities like this. What's your takeaway? What strategies are you going to begin to share? Are you going to talk about those foundational facts and the derived facts? Are you going to maybe do a multiple representation activity like the one I shared? Or are you going to start embedding more games, more explicit teaching through the use of games in your math instruction? That leads us to phase 3, quick recall. With quick recall, it is important that we are assessing fluency regularly. We are assessing multiplication fact fluency to drive our instruction, to drive our interventions, and to help students acquire proficiency. In order to know which kids and which facts we need to assess and monitor, we need to move from the thought on the left, my students don't know their multiplication fact, to the one on the right. What facts do my students know? What strategies are they using? When we're able to acquire this information, we can then strategically plan how we're going to support them. Simply stating that our students don't know their multiplication fact is not helpful at all. You're probably thinking, Carolyn, you said we're not going to just give those time tests. You're absolutely right. As teachers, we are so used to assessing fact fluency with traditional time tests. That is what we experienced as a child, and we turned out okay, so it must be the thing to do. Well, I think we've already addressed that that's not necessarily the case. What should we do now? Well, it is still okay to provide these types of quizzes. I'm not going to make it timed. However, I'm not only going to focus on students getting the answer to the multiplication problem. Instead, sometimes I am going to focus on the strategies they use, the number of strategies they've used. So on this particular sheet that I provided for you, it says complete as many problems as you can and share the strategy you used to determine the product for each problem. Did you use mental math? Were you drawing arrays? Were you using repeated addition maybe in your head? Did you have to draw pictures? At this point, all of these options are perfectly acceptable. Yes, we'll go through and see if they got the right answers, but ultimately you see at the bottom, the score we're going to put is the total number of strategies used. What is this doing? It's doing 2 things. 1, it's allowing them to practice simply the multiplication piece, but 2, it is also encouraging them to utilize the different strategies. And it's providing validation that utilizing these strategies is an excellent way to come up with the answer. It's not something that's frowned upon because it takes a little bit longer. And just remember, the more they utilize these strategies, the quicker they get. So it's a win-win situation. Another great way is is simply using an observation log. You can observe your students as they're learning these facts, as they're utilizing them in context. Maybe you walk around, they're doing 3-digit by 3-digit multiplication or 4-digit by 2-digit. That's okay, because embedded within those, they're obviously still working on simple multiplication facts, such as 3 times 4, 5 times 2. As you walk around, you can ask questions, you can observe what they're doing, and you can mark things down on this log. You might have a 6th grader who is still in that phase 1. They do not have that number sense, and you see them simply counting on, feeling frustrated because how are they supposed to do a multiplication problem that's 3 digits by 3 digits when they can't successfully figure out 5 times 3. Yes, it's heartbreaking and we have some work to do, but at least we know where we need to start. Then maybe you have some students who are in that phase 2. They've got the foundational facts, but they're still struggling with deriving facts, using those strategies to come up with the answers to more difficult combinations. Then maybe you have those who are in phase 3. Okay. So it's important that we not only walk around and take mental notes, but we actually take written notes and write down our observations so that we know how to scaffold our instruction to support various students. A log like this is helpful, doesn't take much time, but lets us get it down. So when we're looking at this log, you'll see that it's left blank if they're still in phase 1 for a particular fact family. It is 1/ if they're in phase 2, where they're still using those derived or foundational fact strategies to solve, which is okay. We just know they need work. Or the X if they're at mastery. They're simply able to come up with the answer within 3 seconds. We don't necessarily know which strategy they're using, but it's working and they're getting the answers. Take notes. Here it says Larry Lope is counting by 2s for his 2 facts. So therefore, he's still using that counting on. So there we go, phase 1, almost into phase 2. So observation logs, great, great resource. I would love to see a high school teacher utilize this and really dive in and dig and find out where their students who are still struggling with their multiplication facts, where are they and what supports do they need? The next thing we want to think about is how can we repurpose our traditional assessments? So we have those fact tests, which is great, but we don't have to reinvent the wheel. Maybe we still give these through high school, but we start off with asking them to solve only the facts that they need to work out on paper or utilize one of the strategies they know. They're not going to go through and solve the ones that they know quickly by memory. Instead, they're only going to solve the ones that they need to work out. Or option number 2, they're only going to solve the ones that they know in their head that they can do with that 3-second recall. Or they're going to solve only the problems with a product greater than 20. Middle school, high school students, great way to encourage that higher level thinking in regard to multiplication facts. And you can see you can use the same assessments that you've possibly been using for that simple quick recall time test to do any of these things. How are you going to revamp your multiplication fact teaching and assessing using some of these ideas? Last but not least, I cannot stress enough that teaching and assessing throughout the grade levels is imperative. Teaching, learning, and assessing of multiplication facts does not stop in elementary school. In fact, it should go on throughout high school. If you look at this chart, I've included it in the handouts. Share this with your team members. Share this with your administration if they're not familiar. All students still need explicit instruction to help them become proficient with multiplication facts if they are not able to simply recall within 3 seconds. It doesn't mean that they need to be embarrassed or feel like they need to go back to 3rd grade. It simply means that they were most likely not given adequate time to acquire the strategies to make them successful. Let's offer them that opportunity. It might only mean that they just need more practice with that quick recall. Maybe they just need those modified assessments, not necessarily timed, right? But where they are just solving for the problems whose product is over 20. Maybe they're just solving ones that are multiples of 5. But just remember that repeated practice helps them become proficient and stay proficient. Share this document. Live by this document and know it doesn't matter what grade you are teaching, you play an important role in multiplication fact proficiency. I hope you enjoyed this session, and I hope you are taking away a variety of strategies to support your students on their journey, wherever they might be right now. If you're working with a group or a partner, I suggest you stop or pause this video and share what your takeaway is and how you are going to utilize something tomorrow in your classroom. I thank you for sharing your precious time with me, and I hope that this has been beneficial and that you're excited to go back to your classroom and start sharing these strategies. Here at Canyon Professional Development, our why is to empower, educate, and inspire our community, that's you, so that you can take action to fulfill your purpose and serve others, in particular, your students. Thank you for joining me and have a great day.